My name is Islam Saeed. Today I'll be presenting the Blood Panel website alongside my groupmate Juan Battaglia.
The complete blood count, or CBC, is the most common blood panel in the United States. However, patients usually are presented with the results without any tools to help them understand what the results might mean for them. For most people, they'll either have to wait weeks to see a doctor to have the results interpreted, or they can risk being misinformed online if they try to take matters into their own hands. Our solution is to create a new patient portal where patients can log in to see their blood panel data with visualizations, and where they will receive a summary of their results and what they indicate generated by a ChatGPT model. The patients will also be able to ask the GPT model questions about the results and get responses immediately. To create this application, Juan, which is myself, took care of the front end and the deployment, while my partner, Islam, took care of the back end and the data.
Next is our achievements. So for the front end, we were able to create a working login page, a visually appealing and logical front page that is organized by date, and integrated some very nice data visualization tools to our front end. Our main goal was to make it simple and intuitive while also looking good, and I think we really achieved that. For the backend, we were able to integrate an AI API, specifically ChatGPT's, and create functions for pulling from it. We were also able to integrate our API key for when we did our deployment and had our application working seamlessly. Lastly, the deployment. We actually had to change from GitHub Pages to Heroku, and that was especially difficult to implement due to having to make some many script changes to get it working. Juan worked hard to get this integration working, and I think it's doing really well right now. Next is the challenges. We had began with a database integration using MongoDB, which we hosted in the cloud. That contained the FHIR standard information for each date, which was saved as observation data. However, after spending a lot of time trying to get that working, we realized we were approaching the end of the semester and decided to not implement a database. That left us with the question of how we would implement our FHIR standards and the data structures into our code. We ended up creating a Python script to transform a JSON with the FHIR standard data into another JSON that's digestible by our application. This was done to simulate pulling data from the database and generating a JSON that could be read from our front-end scripts. Lastly, the deployment. As I mentioned before, we started out by posting our development on GitHub Pages, but quickly realized we needed a backend, which is why we ended up changing to Heroku. We needed a backend to handle our APIs. Therefore, the switch to Heroku was made by us, and Juan took charge of making that change. This challenge was one that ate up a lot of time because of all the script changes we needed to make it compatible with Heroku. So this was a really interesting challenge. Our main research was into the FHIR standard and what that would mean for our project. We wanted to make sure our data was in the correct FHIR standard format and data structure before we pulled and transformed it into something digestible by our project. We ran into some complications while working on creating a database and pulling the data from it. So we created functions instead to pull that data from a JSON that contained the FHIR standard data and then transform it into a format that we could use on our front end. We also did some research into blood panel data and information, as well as some small calculations that are included in a CBC, like mean corpuscle volume or hemoglobin levels. Lastly, we did some initial research on a coding stack and visualization tools that we could integrate well together. We ended up choosing React and Node.js since they're fairly lightweight, and this is a fairly lightweight project. And I will be presenting the final demo for our project, which is a blood panel assistant website. For our deployment, we used Heroku, which can be accessed through this following link right here. This will also be in our project details. Okay, so the first feature I want to discuss will be the login. Each user has their own working login where their information is locked behind. The login page is working, so if you put in the wrong information, as I'm about to do now, by adding this one at the end, you'll get a rejection. So you have to put in the correct information, and then you'll be able to access the main page. Once you are here, there's really three main points to this page that I want to discuss. The first is in the center here, which is the test results. We have in the center of the bar that displays the data, the green, which denotes normal values, and then past that on either the left or the right is low or high values respectively. On the right of that is the AI summary that is generated for each set of data based on the user's specific information and the date that's chosen. You can also ask questions here at the bottom about the summary, which I will demonstrate shortly. This brings us to the third major part of the website, which is choosing the date. That's over here at the top left corner. You can change it here to display data based on whatever data you want to see for whatever date you want to see, and then the summary will regenerate over here on the right based on that data. This also works if you change the user. So if I change out of John Doe and go to Jane Doe, you'll get a new summary dynamically created based on the information. Now back to the question. Once the user reads the summary, they're able to ask any question they want to the AI and have it generate a response. So for example, if the user saw that their MCHC was high, they could ask about that. Even if they panicked, they could tell the chatbot to give them a response based on that. For example, they can send that question to the chatbot, which will then generate a response. The AI will, of course, reassure them and then always recommend that the user see a health care provider. It's also careful to avoid giving outright diagnoses and is also strict in the information it responds with. Unrelated information or freakouts can be met with that calm, collected response that recommends they see a healthcare provider. It'll also be strict about not giving answers to things that are completely unrelated. For example, something unrelated would be met with a strict response to tell them to get back to it. The last thing I wanted to show was our code. I wanted to demonstrate the functions we wrote, which take care of generating our FHIR data as well as converting it to our website digestible data. The first function I wanted to show is generate FHIR.py. This function is designed to randomly generate the blood panel data somewhere along a Gaussian distribution that we created with normal values and standard deviation values outside those normal ranges. This script will generate a JSON file called FHIR_bundle.json. This is all the information for both of our current patients in the FHIR standard. The next function, which is compress FHIR.py, needs to be run after that first function. It takes the firebundle.json as input value and then generates another JSON called patients_data.json, which is essentially the same thing, but just in a digestible version for our front-end code. All of these were generated beforehand and put into our production data folder that was used in our website. In the future, more data can be generated for each user for more scaled testing before moving on to future work with real FHIR databases.
Looking into the future, there are a couple things we could do to improve our application immediately. The first thing we could do is to pull data from a real HappyFire database. Right now, we just have our own generated Fire data, which is stored in our front end. The other thing we could do is to create our own database for storing user history, such as their previous chats and their previous blood panel results. This could come in handy because we could give this data to the GPT models who could interpret all the data at once to create more tailored summaries and responses for the patients. The last thing we could do immediately is to have a more secure authentication server for user logins. Right now, we are doing all the authentication inside of the front end. Looking at some additional areas of improvement that we could research are the HIPAA standards for data security and privacy. And we could also look into training our own LLM model using Llama 2 or something similar, because this would be a lot cheaper than using ChatGPT in the long run if we scale our application. Some other domains that could be served by our application or a similar solution would be other blood tests such as the basic metabolic panel or BMP, which is also very common, or other medical lab tests such as urinalyses or cholesterol tests or thyroid tests. In conclusion, our application addresses the problem of patient confusion and seeks to generate more informed patients. A patient might know that the results came out abnormal, but they won't understand what that means for them until they have the results interpreted professionally. Our solution provides an individualized tool where patients can view, visualize, and understand their data, and where they can ask questions and receive immediate responses. Thank you for watching, and we hope you enjoy using our application.